Hello everyone, I welcome you all to this video tutorial, and in this video tutorial we'll be going through Garuda protocol. So before we get started with the Garuda protocol, that which is a transport layer protocol, let's first see how exactly data movement occurs in wireless sensor network. So this wireless sensor networks will be containing lot of such nodes that which forms a cluster based on the vicinity, and out of that cluster a specific node will be considered as a cluster head. So all these nodes will sense its environment and will send the data to its cluster head, and in turn this cluster head will forward the aggregated data to the main sink. So likewise there will be a lot of such clusters whose cluster head will be forwarding their aggregated data to such sinks, and in turn sink will transmit its data to the internet via this gateway, and ultimately the users can access the data via this internet. So this sort of data movement that which is happening from the nodes to the sink is called as forward data movement. So when the data flows from nodes to the sink, we call it as forward path data movement, and this data carries the sensed event in the environment or features of the environment. And the data communication can also happen in the reverse direction, that is from the sink to the nodes, and the data in such kind of scenario will be from sink, and it is for application specific purposes, and the data includes operating system binaries, programming configuration files, as well as application specific queries sent from sink to the nodes. So here event to sink approach is not suitable, and it is not reliable for reverse direction data flow. Sink with plentiful energy and resources can broadcast data with its antenna. The amount of traffic forwarded in the multiple hop wireless network infrastructure can be reduced, and this leads to less congestion, whereby reliability is important in reverse path. The reverse path consists of multi-hop as well as one-to-many flows. In Garuda protocol, that which is a part of transport layer protocol, provides reliable delivery between a resource-rich sink and resource-constrained sensor nodes. The name Garuda is based on a mythological bird that reliably transported gods. Garuda incorporates an efficient pulsing-based solution for successful delivery of single packets, like an RMST, that which stands for Reliable Multi-Segment Transport Protocol. Certain nodes are selected to perform caching and manage loss recovery processes. Such kind of nodes that which are shortlisted are called as core nodes, and this Garuda protocol mainly relies on such core nodes. So this involves two-stage loss recovery mechanism and is incorporated for each node in the network to reliably receive packets from the sink. Garuda protocol incorporates three main mechanisms. One is single or first packet delivery, where Garuda mainly follows a negative acknowledgement based recovery policy for the lost packets. Pulse-based delivery mechanism is incorporated so that the sink informs the sensor about the subsequent delivery of a single packet flow or first packet of a multi-packet flow through short duration pulses. The second mechanism is core construction. Garuda relies on core nodes for caching. It is simple as well as efficient. Core construction mechanism is designed to select these nodes without significant overhead. Two-phase loss recovery. Once core is constructed, information delivery is performed through core nodes. In case of packet losses, a two-phase loss recovery mechanism is used where a core node first recovers the lost packet from upstream core node and then delivers the packet to the neighboring non-core nodes. So this is how Garuda protocol works, and we'll be going through how exactly this pulsing system works in our next tutorial. Thanks for watching.